In this lecture, we will be discussing short-term memory. Short-term memory is very important as it allows us to temporarily preserve information required for us to complete a task in our minds at the present moment. So hopefully after learning a bit about sensory memory, we've grasped the idea that some information passes through our sensory memory for further processing by the working memory. Why is this? Well, information that we perceive as relevant or significant will move on to our short-term memory because this stage in processing allows us to hold on to information for a longer interval. Simply put, the duration of short-term memory is longer than that of sensory memory. It's referred to as the working memory because it allows us to hold on to and manipulate information as needed in the present moment. So let's imagine we're completing a math problem. It'd be pretty inconvenient if we had to refer back to the math problem each time to see what we had to do next to find the solution. So our short-term memory helps us hold on to those numbers, such as 27 or 4,000, so that we're able to work with them in the moment effectively and accomplish our task. After your math exam, you may notice that if your friend were to ask you what you got for all those various different answers, you'd likely be unable to recall them. That's because our short-term memory doesn't last forever. In fact, the duration of our short-term memory is no longer than about 20 seconds. And that's true if you're not engaging in any repetition or memory enhancing techniques. Now, in the example that I was discussing with the student taking the math exam, this number may be extended by a bit as the student is likely engaging in some unintentional rehearsal of the numbers inside their head. I won't be going in depth on the topic of rehearsal for the sake of this lecture, but you will learn more about it in your Intro Psych course. So, George Miller discovered that the working memory also has a limit to the pieces of information that it can store at one time, and this is known as the magic number. The magic number of information that we can store in our short-term memory is 7 plus or minus 2 data chunks, and this rule applies to just about everything, including numbers, letters, words, names, images, and cities. If you have an excellent memory, you may find it easy to remember a random slew of 9 numbers after a brief exposure, but it's pretty unlikely you'd be able to recall 10 or more because of this rule. Now, on average, we have the capability to remember 7 bits of information at once within our working memory, which is very helpful as it enables us to remember telephone numbers with just enough time to dial that number before it vanishes from our memory. And it's really no coincidence that most telephone numbers are 7 digits. It's because of this magic rule that we're able to remember them. But why do we forget? How come we aren't able to remember 20 data chunks or short-term memory events for 50 seconds instead of 20? Well, researchers have found 2 primary reasons for our forgetfulness. For one, we know from research that the short-term memory decays. It fades away with time, and the more time that passes, the less likely it becomes that we will recall a memory-encoded short-term. One possible physiological explanation for this phenomenon is related to the birth of new neurons in the hippocampus. As we experience new memories and neglect older ones, new neural pathways form in our brain, while the old ones become weaker and eventually fade away, leading to memory loss. And this is kind of akin to the old adage, use it or lose it. Another explanation for our propensity to forget what is stored in our short-term memory is known as interference. We experience interference when our own memories get in the way of one another. Sometimes our new information interferes with our ability to recall older information. This phenomenon is known as retroactive interference. My family is Italian, and my parents have used the Italian language frequently in the house and throughout my childhood. I never fully learned the language, nor did I take any Italian classes, though. My high school offered Spanish, which I took for several years, and then continued to take for several years in university. Now, I found myself suddenly having troubles recalling Italian words that I used to know and which used to come clearly to my memory because my brain began rewriting them as Spanish words. My knowledge of a new yet similar language, Spanish, had interfered with my brain's ability to retrieve information from the language I was first exposed to, Italian. This explains why I might tell my parents I will be home at 8 della notte instead of the similar Italian pronunciation 8 di notte. To remember this, we can identify that retro means from the past and interference indicates a disruption of past information. My troubles with Spanish and Italian did not end there. At times, I struggled with the opposite problem. I experienced what is known as proactive interference, whereas my previous knowledge of Italian interfered with my ability to properly recite Spanish in high school and university. So this occurred in an exact opposite fashion from retroactive interference. It's when old information interferes with our ability to recall new information. To step aside from that language example, I'll bring forth a new example. Have you ever struggled to write down the correct year shortly following New Year's Eve? Maybe in January of this year, you mistakenly wrote down 2020 instead of 2021. That's because your brain had strongly encoded an old memory, last year's date, and it's struggling to retrieve newer information, the year that it is currently. So to remember this, we can identify that to be proactive is to focus on the future. Thus, proactive interference denotes a trouble creating new or future memories. This can be a bit challenging for students to grasp. I want to take a brief pause to summarize what we have learned about so far. So, the short-term memory is referred to as the working memory because it enables us to take hold of relevant information for a long enough duration to accomplish tasks. The duration is about 20 seconds long, or 7 plus or minus 2 data bits. That's also known as the magic number. And we're constantly forgetting things that are held by our short-term memory. There are a couple explanations for this forgetfulness. Memory decay occurs when we fail to use information, and subsequently, our neural pathways fade, causing us to lose information. On the other hand, interference occurs when our memories get in the way of each other, thus causing us to forget. Retroactive interference indicates you have trouble recalling old memories because of new ones, while proactive interference occurs when you have trouble forming new memories or retrieving newer memories because of interference from the past.